Hi everyone. In this video, I'm going to show you how to use the MATLAB to simulate the solar cell. Okay, so first of all, this is the circuit I'm trying to simulate. So actually, in fact, the solar cell consists of a current source connected in parallel with the diode, then connected as well with the transistor, and this combination will be connected with a series resistor. Okay, so this is like the schematic diagram for the solar cell that we gonna simulate today. All right, so this is the MATLAB uh, workplace. Then I need to open the simulink. Okay, so in the simulink, the first thing I need to build my own circuit. So I need first to select all the components that I need. So first of all, I need to select based on the schematic. I need to select current source, then diode and resistors. Okay, so going back to the simulation, I need to go to the library. So inside the library, I can find like different type of library. Then in our simulation, we need to go to the semiscape. Okay, so there's actually two ways to find any component. The first way is to just search the component inside the libraries. And the other way, you can write down like what's the name of the component and it would show you straight away. Okay, let's start with the first way. So first of all, I need to find a current source. So on the current source, I go to simulink and foundation library. Then inside that, I'll go to electrical source. Then I can find there is too many type of the component. So I can choose even a control current source or just a DC current source. Let me go with the control current source. Just add it to the workspace. Okay. Then after that, I need to have a diode. So again, in the simulink, I need to just have a look inside the library, go for example in the passive component. Okay, then I need to just have a look and find where can I find the component. So here, if you can see, I can find like the diode just right here, just add it to the circuit. Okay, or the other way, I just type like resistor. So here, show me all the resistors that are available in the simulink. Then I need just to add two of them. Okay. You'll find here that all the components that I select before, it's available here. So let's start with just connecting all these components. So based on the schematic, so this is the order of the components. So just current source, a diode, then just let's press on the Control and R. Okay, then the element will be rotate. Okay, so this is the diode, just need the diode in parallel. Okay. Now I need just to connect this component together. Okay, so now the circuit is ready. However, to test the solar cell, I need to connect it with a variable resistor with a different load. So to do that, I need to have a variable resistor. So in the resistor values or elements, I can find a variable resistor, just add it. Take it. Okay. So actually the variable resistor is not part of the solar cell, but we needed to just test if the solar cell is working and how we can change the impedance, then we can generate different type of power, different amount of power. Okay, so this is the circuit here has been built. Now, to control the circuit, if you can see that we need two controllers or like two variables to just modify the value of the current source and the output impedance. So to control the input current source, I found just constant value. So just type constant. Okay. For the impedance, actually, I need to change it like not in a constant way. I need to change it like in such a way to be even like exponentially way, or like using the equation for the xy equation. So just type like ramp function maybe. Okay. Now I have the ramp function for the output, the input for the input. Okay. Now what I need to do, I need just to connect this constant with the current source. If you can see here that when I try to connect the constant with the current source, actually I'm not able to connect it. So the reason behind that I'm using two different type of elements. So the first element here is related to the simulink element, but this element here is actually a physical element. So to connect these two parts, like it's from two different families, so I need to have something to convert the signal from the first part to the other part. So again, I go to the library. If I go to utility, I can find these two different type of converters. So the first converter between physical to the simulink, the second one from simulink to the physical. So in fact, I need to convert the simulink to the physical. I need two of them. Okay, let's see now. Just connect them together. I'll rotate this one. Okay. What I need to have ground for this circuit. Just type ground. Okay, so the ground is here. Okay, so to run any simulation, I need to have a solver for that simulation. Solver. Okay. So if you open the solver here, you can see like this is how you want the simulink to solve this simulation. So it has some like parameter. I'll just keep it as default. Okay. So now if you see here that the circuit is already built, I need just to modify like the values for this element. So starting with like a current source, I have to do nothing, just I can change the value of the input current. So we'll start with 0.5. For the diode, I have to select an exponential diode to make it more realistic. Okay. All right. For the shunt resistor, in fact need to be as high as possible. So I keep it like 1 kilo ohm. A series resistor actually, it should be like very low. So let me use 0.2. Okay. All right. Okay. So if I run the simulation here, I can find like, okay, the circuit is working. However, I can't see nothing. So actually, in fact, any simulation or not even the simulation, if you do the experiment in the lab, you have to have some devices that connect with the actual circuit to see the waveform. So in the lab, actually, we have the oscilloscope or digital oscilloscope. So the digital oscilloscope will be connected with the circuit to measure the waveform. So in the simulink, we have something similar. We call it the scope. So the scope is actually something similar to the digital oscilloscope. So I'm using the scope now. Okay. All right. Okay. So here's my scope for this simulation. So what I need to do, I need to connect this scope with the circuit. Okay. So what I need to measure the output voltage and the output current. So as you know, to measure the voltage and the current, you need to have some tools to measure the voltage and current. So normally we use like the current probe to measure the current and the voltage probe to measure the voltage. So here I have to use something similar. So if I use sensor, okay, if you see here, there is two types of sensor. We have a current sensor, we have a voltage sensor. So I need to use both of them. Okay, so here's my voltage sensor, here's my current sensor. Okay, so how can I connect them? So normally the current sensor should be connected in series with a circuit. So I just place the current sensor in series in this circuit. And the voltage sensor need to be connected in parallel with the output. Okay. All right. So now the circuit is okay, connected with the sensors. I need to do some modification in the scope to measure by using two channel. So if I go to view, configuration, the configuration number of input, I make it 2. If you see here that the scope now has 2 inputs. So the first input here will connect it with the voltage. Okay, so now I need to connect the sensor with the with the scope. However, when try to connect the sensor straight away with the scope, it not allowed me. The reason that again I'm using two different type of element in the simulink, so I need to have again the converter. So utility. Now I need to use physical to simulink converter. Two of them. Okay. So I should be able to connect the circuit. Okay. Okay. If you see here, there is two graphs for the current, one for the current, one for the voltage. Just make it change the layout. Okay. Vertical. Okay. So if you see here, like once the impedance is changing, that the current and the voltage will change as well. So these two graphs, one for the voltage and one for the current. And you can notice here the relation between the impedance and the voltage or the current is not linear. That makes like dealing with a solar cell more harder. All right. So what I need to do, I need to have the IV curve or the PV curve. If you see here, there's the relation between the voltage and the current and the voltage and power for the solar cell can be represented by these two curves. So I need to just represent this relationship between the voltage and current. So what I need to do, I need to use again scope. Okay, I can use XY scope, then again, can connect voltage, I can connect the current. Running the simulation. Okay, you can see here, there is here that the IV curve for this solar cell. However, it doesn't look similar to this curve. So the reason behind that, this curve is start from -1. So I need to just modify the curve to start. So the minimum value will be 0. Minimum value 0. Run the simulation again. Okay. So here I have my IV curve. If you see that the curve actually not able to reach to 0, the reason behind that that the impedance is very low. So I need to go to the RAM function, just increase it a little bit and see what's the effect of the output impedance on the solar cell. Okay, so this graph now look more realistic, but this is the IV curve. So how can I plot the PV curve? If I multiply the voltage and the current, I will be able to find the power. Just I use a simple multiplication. Okay, if you see here that connecting all this wire will be like some headache, so I can use some label. So just type O2. Okay. Okay, so this is I can use this label just to simplify my circuit. So this is will be output current. So I can delete all this. Copy. And I need V out as well. Okay, just click on the component. Just okay. Now the current are connected here. Again, drag and drop the voltage. Copy base. So what I did here is just multiply the current and voltage together. Then I can calculate the power by plot. Okay. Okay. So this is the PV curve I'm looking for. Let's see if we can. Okay, so this is now my signal. So this is my PV curve. I can just copy paste and plot again. I need to show you two curves, like the IV curve and the PV curve together. Okay. So here I have two curves. One is the IV curve and the other is the PV curve. If you see here that when I change the value of the input current, then this curve will change as well. So make it 0.7. So if you see here the output power, the maximum output power around 0.3. If I increase the input current, then I should be able to get more power. So now I'm able to get around 0.42. Okay, so this is roughly the simulation for the solar cell by using like the simplest structure for the solar cell. Okay, in fact, the MATLAB has a library or like a module for the solar cell. So just type that the solar, then I can find like there is different type of elements. So if I select the solar cell, if you see here, this is actually the solar cell that I'm trying to do in this this simulation. So here, instead of connecting this component, I can just straight away use this solar module. Okay. So if you see here, the input for this circuit will be, then I have to select the value for the radiation. Let me see, 700. Again, there is some parameter inside this solar cell, so you have to select the parameter based on the data sheet for the solar cell that we use. So the one that we use, it gives us around 0.49. Okay, if I run the simulation, I should be able to get something similar to the simulation that I had before. Okay, so this is the IV, the IV curve. This is the PV curve. Okay, so what I will ask you, so now to try to find how many solar cell we need to connect to generate or module 1 PV panel. Okay, and try to see what's the difference between using like your own simulation and by using the actual solar cell. And if you go inside, try to change some of the parameter to be accurate with the solar cell that we use normally in the lab. Okay, thank you. And if you have any question, please contact me.